Hey everybody, welcome back. We're going to continue to talk about enolates and enols as alkylating groups. Now, just really quick, I want to run through the mechanism again of what happens if you take, say, methylethyl ketone, or 2-butanone as it's more commonly known. You react this with 1 mole of sodium hydride followed by 1 molecule of 1-bromobutane. What you get here is this. 1, 2, 3, 4. Now there are a few reasons we would know we would get this. So let's break those down, starting with the location of that enolate. Well, let's back off that just a little bit further. Let's go ahead and say we know that this will be an enolate rather than an enol. And here's why. 1, we're using a strong base, which always points you to enolate. Acids, strong, weak, or otherwise, point you to enols. Now, the second question here is, so now that we've established that this is what happens, hydride removes the proton. And as a quick reminder, this is where I have a fundamental disagreement with your book, because I present the enolates as this form, whereas your book prefers to present them as this form. Both are correct, and both of these are correct. And if you choose to go with this form in blue, which is what the book prefers for your mechanisms, etc., I can't fault you. I won't mark it wrong. It's just I vastly prefer to go with the enolate itself over here in the orange. Now, the question becomes, why will this enolate form over, say, this enolate? Why enolate orange over enolate red? And the answer to that is enolate orange would be preferred because the alkene that you make is more substituted than in enolate red. And boy, Zaitsev didn't really nail down a hard and fast rule, but by golly, he knew what he was talking about when it came to the substitutions of these carbon-carbon pi bonds. So we know that enolate red is not the enolate that will form. In fact, I'm going to go ahead and erase it so I can continue on this side I've got going on here. Okay, so we know this enolate, we know why it will form regiochemistry-wise on that carbon. Let's talk about our alkyl halide. I think it was 1-bromobutane. Let me check that again. Yes, it was. So the question becomes, how do we know where this will nucleophilically attack? Just a second, I need to turn off my phone's alarms. My research students have started what I like to call meme storm. Okay, so this would be the nucleophilic attack we would do. And this is what I'm not sure that I pointed out yesterday or the previous video that we did. You always have to use primary primary alkyl bromides. Because this mechanism counts as an SN2. So you have to use primary. Secondary is occasionally acceptable. But by and large, we're looking at primary alkyl halides. So this is the mechanism here. The last thing I want to point out is why I felt the need to specify 1 mole of sodium hydride. And the reason for that, and I'm just going to redraw it over here. The reason I specified 1 mole as opposed to just some or excess is this carbon right here has 1 more proton that can be removed. In fact, if there was any extra base sitting around and that proton was removed and you get this enolate, I am quickly running out of space here, so I'm going to erase the blue enolate at the bottom. What we would get is this. Oops. We would get that enolate, which is really, really stable because of the level of substitution you've got. That actually would probably be the most stable enolate you can get right there. Unless you threw like something really electron withdrawing on there too. So now I have a puzzle for you. Here's what I want you to do. I want you to take this reaction. I want you to take this diketone, which is spelled diketone for those of you wondering. I want you to take this diketone and I want you to react it with base, and I'm going to let you choose the alkyl halide of your choice. But I will tell you that this is what I want for the product. And for those of you who are thinking, wow, he is being so precise with his pen strokes now. It's really impressive. I wonder if he did this so we can understand and see things better. You would be absolutely right, ladies and gentlemen. So what I want you to do is show me how, using base, and you can assume it's a base that works, say NaH or LDA, or frankly, you could use hydroxide here because it is a diketone and the pKa is pretty low. What I'd like you to do is show me how to make this particular product. All right? The big red box, I want you to show me what the reagent you would use to do that, and I would like you to show me the mechanism. And I want you to do this. I'm not going to give you the answer. If you have questions about it, please feel free to email me or make a comment in the section below. This is the point where I become a very needy YouTuber and I say like and subscribe, please like and subscribe me. No one loves me. At any rate, that's all I have right this second. So come back next time and we're going to talk about some other fun stuff.